Hi everyone, I welcome you to my channel, and today we'll be discussing questions on continuity, and this will be lecture 2 on this particular topic. And yesterday we have uploaded the first video on continuity. Of course, previously also I uploaded the videos on continuity, and we have just started revision classes. Okay, and we have taken a few important questions, and so these questions will definitely help you for your preparation of class 12 board exams. And this will be the first questions for today's class. And what you have to find out, you have to find a value of if this function fx is continuous at x equal to 0. Okay, we know that if the function fx is continuous functions, then left hand limit and right hand limit and the functional value will be same. So we'll just solve step by step. First we'll just try to find out that either left hand limit or right hand limit. Okay, so let's move to this. Okay, next page. So we'll start with left hand limit. Left hand limit. Okay, limit x tends to 0 minus fx, that is limit x tends to 0 minus. Okay, fx. So we need to check that. What is fx? Fx is a sine pi by 2 x plus 1. Okay. A sine pi by 2, a sine pi by 2 x plus 1. Right? For x approaches to 0 minus, so the function is given as a sine pi by 2 x plus 1. And if x approaches to 0, if this x is approaches to 0, this will be a sine pi by 2, right? A sine pi by 2. So pi by 2 is equal to 1, so this is equal to a. So therefore, left hand limit is equal to a. Now just find out the right hand limit. So let us find out the right hand limit. The right hand limit x approaches to 0 plus fx. Then limit x approaches to 0 plus. So what is the value of fx? Fx is this. So what is fx? Fx is this 10x, because if x is greater than 0, for x greater than 0, the function is 10x minus sin x by x cube. Okay, 10x minus sin x upon x cube. So this is equal to limit x approaches to 0 plus. So what I'm going to do is, okay, from the numerator, we'll take sin x common. So if we take sin x common, so 10x is sin x by cos x. So if we take sin x out, so remains as 1 by cos x minus 1, right? Yeah. Next, what's the next steps? Limit x approaches to 0 plus. Okay, so let us first simplify two steps. X cube. So why we need to simplify? So because this is, right, this is given in 0 by 0 form. So we'll just try to remove the 0 by 0 form. We'll just try to remove the indeterminate form. Okay, so now sin x. So if we take LCM, that is this gives us 1 minus cos x, right? This cos x, you can put it down, like cos x into x cube, right? Cos x into x cube and sin x into 1 minus cos x. Okay, now let us further simplify. We can just write the next steps like that. Limit x approaches to 0. So we can just write sin x by x. Okay, because use a theorem. The sin x is there, here x cube is there, so you can just write sin x by x. Then, right, this is 1 by cos x. You can just write, you can separately 1 by cos x. And what will be left out is this. So, x2, because 1x we are using with sin x by x, x cube 1 minus cos x. So 1 minus cos x you can write in terms of sine. That is, this gives us what? 2 sin squared x by 2. Fine. So these are very simple steps. The moment you have seen sin x, so you know like you are going to use the sin x by x theorem, that is sin x by x. Then you can just write cos x there, you can write in the form of 1 by cos x. And then what will be left out here? That is x square will be left out. So 1 minus cos x you can write in terms of sine, that is 2 sine square x by 2. So this gives us what? So we can just write the next steps. Okay, we'll just take the limits separately. So limit x approaches 0 sine x by x. Okay, limit x approaches 0 sine x by x, okay, is equal to 1. This is 1. Then limit x approaches 0 1 by cos x also equal to 1. Then limit x approaches 0. Okay, this is 0 plus 0 plus. Then you can just write this one is sine. Okay, sine square x by 2 can be written as sine x by 2. 2 is there. And sine x by 2. So sine square x by 2 can be split out like sine x by 2 into x by 2. So this x you can just write x into x. So you can just write x upon 2 and x upon 2. So then you can just use sine x by 2 by x by 2. That you can use the sine x by x theorem. Okay. So now this 2 and this 2 is extra. So you can just multiply it by 4. Right? Sine x by 2 by x by 2. So if I can just mark this. So this is, you can use this step, you can use a theorem for this step also, sine x by 2 divided by x by 2, you can use the theorem. So if you take the limit, okay, if you take the limit, so it's 1 and 2 is there, 2 by 4 is half out. So limit x approaches 0, sine x by 2 by x by 2 and sine x by 2 by x by 2 is 1. So this is 1, so e is equal to half. So right hand limit is equal to half. Right hand limit we got is half, and the left hand limit we in the previous case the left hand limit was this is a. So therefore a equal to half. Since the function is continuous, left hand limit will be equal to right hand limit. Okay, next we'll be taking another very important questions. Okay, and this type of questions are also very important for your board exams. So related like that, many more questions are there. Please just go through the steps properly, and you need to solve a similar kind of questions. Okay. Now, what is given? If fx is equal to this function sine a plus 1x plus 2 sine x upon x, x less than 0, and fx equal to 2 for x equal to 0. And fx is equal to square root 1 plus bx minus 1 by x, x greater than 0. Okay, it's continuous at x equal to 0. What is given? The function is continuous at x equal to 0. Then there are two unknowns. One is a, one is b. So we need to find the value of a and b. So we'll just, like the previous questions, we'll just find out the length and limit. And then we'll find out the right hand limit, and we'll equate with the functional value. Okay, because we have two unknowns, we need to find out. So let's start with this. Okay, yes, solution. Left hand limit. Okay, so limit x approaches to 0 minus fx. So this gives us limit x approaches to 0 minus. For x approaches to 0 minus means x is less than 0. So x less than 0, the function is this. Okay, that is sine a plus 1x plus 2 sine x by x. Okay, so we can simplify these steps like that, right? Let us see what is the form. Like for x approaches 0, right? This will be a 0 by 0 form. That is, it is given in indeterminate form. So try to remove the indeterminate form. So the first term can be written as sine a plus 1x, and denominator also can be written as a plus 1x. Then, right? So let's just separate the terms. First, this is sine a plus 1x by x, and plus 2 sine x by x. So we'll separate the first term. Sine a plus 1x is already there, and denominator only x is there. So just multiply by a plus 1. So we need to, right, multiply the numerator by a plus 1. Okay, so now next 2, then sine x by x. Fine? Yes. These are simple steps. I hope you can just definitely follow the steps. Sine a plus 1x, and with x we have multiplied by a plus 1. Okay, so this a plus 1, which is you multiply in the numerator a plus 1, then 2 is there, and you can write this expression that sin x is sin x by x. So if you use the limits now, okay, for x approaches 0, so this will be sin x by x. So this will be equal to 1, only a plus 1 will be left out. So you can just write the steps here. So what will be left out here? The first term, this will be equal to 1, only a plus 1 will be left out, right, plus, and here 2, this limit x approaches 0, sin x by x is 1, so only 2 will be left out. So this gives us what? This gives us a plus 3. Yeah. So we got the left hand limit as a plus 3. So let us try to find out the right hand limit now. Okay, right hand limit. Limit x approaches to 0 plus. Okay. Limit x is to 0 plus. What is the value of fx? Fx is 1 plus root 1 plus bx minus 1 upon x. Okay, so let's check the steps. Right, what is that? Yes, root 1 plus bx minus 1 by x for x greater than 0. Yes. Now let's check the steps. Let's check the form. So for x approaches 0, this will be 1 minus 1 and denominator also 0. So it's given in 0 by 0 form. Right? This is irrational terms is there and it is given in 0 by 0 form. So we need to remove the indeterminate form. How can you remove in this case? So we'll just try to rationalize the numerator. So what we can do is root 1 plus bx minus 1. So just can multiply the numerator is root 1 plus bx plus 1. So therefore denominator also to be multiplied by root 1 plus bx plus 1. That's all. Okay. So we try to remove we try to convert the numerator to rational expressions. So therefore we are multiplying the numerator root 1 plus bx minus 1 by root 1 plus bx plus 1. Okay. So what's the next step? So this gives us limit x approaches to 0 plus. Fine. So leave the denominator as it is. So x root 1 plus bx plus 1. Okay, so this is a minus, this is x, a minus x, a plus x, right? So can you use a square minus b square formula? That is 1 plus root 1 plus bx whole square gives us 1 plus bx and minus 1. So you can cancel this 1 you can cancel. That is a minus b, a plus b, a square minus b square. So root 1 plus bx whole square is 1 plus bx, and what is b? B is 1. So 1 square is 1. So you can cancel 1 and this x you can cancel it. Right? Yeah. So this will definitely make the question very, very simple. So next, limit x approaches to 0 plus. Okay. So what is left is this. This is b under root 1 plus bx plus 1. Fine. So now 0 by 0 form is removed. So we can actually find the limits now. So if we take x approaches to 0, so numerator is b and this term will become 0. So root 1 is 1, 1 plus 1, 2. So therefore this is a right hand limit. The right hand limit is a equal to b by 2 and we got the left hand limit as, I hope, a plus 3. So we got this one. Yes, I hope. Yeah, the left hand limit we got is a plus 3 and the functional value is given as 2. So yes. Okay. Also functional value, that is f0, is given as 2. So since functional value is 2, so we can just write now left hand limit, that is a plus 3 equal to right hand limit, that is b by 2 equal to the function value 2. So you can compare this, right? And therefore, so if we just compare the first term and the third term, a plus 3 equal to 2, therefore a plus 3 equal to 2 gives us what? A equal to minus 1. So you got a value of a, that is a equal to minus 1. Now b by 2 equal to 2, right? B by 2 is equal to 2. This gives us b by 2 equal to 2. This gives us b equal to 4. So the steps are as simple as this. Okay, so you definitely can expect like that questions for your board exams. And thank you for watching my channel, and if you have not subscribed my channel, please do subscribe, and don't forget to press the bell icon. Okay, next I'll be uploading videos on differentiation, important questions. Okay, till then, bye bye and take care. Thank you.